Welcome to the deep dive. Today we're getting into something that should be impossible. We're looking at how to send ultra-high-res video. We're talking 4K, even 8K, over massive distances.
Right, and without signal boosters or anything like that.
Exactly. The problem really is that standard copper cable just gives up after, what, maybe 50 feet at that kind of bandwidth?
If you're lucky.
So our mission today is to unpack these active optical cables, or AOCs. We're looking at DVIGear's Hyperlight line, which basically claims to, bend the laws of physics.
And it really comes down to the numbers. I mean, what's fascinating is the sheer bandwidth. These cables support DisplayPort 1.4 using HBR3.
High bitrate 3.
Yeah, and that gives you a massive 32.4 gigabits per second. That's what lets you push 8K video at 30 hertz. Or, and this is crucial for pros, 4K at a full 60 hertz.
And with full 4.4.4 color. So completely uncompressed.
Uncompressed, true-to-source video, and they do it over 100 meters. That's 328 feet. That kind of distance just completely changes how you can design a large video installation.
Okay, that 100-meter range it's huge. We know copper fails because of resistance, signal loss, all that. So how does this AOC technology actually pull that off? How does it keep that 32.4 GBP speed?
Well, it's a hybrid approach. It's not pure fiber optic.
Oh, interesting.
It's a mix, a necessary one. You have 4 glass optical fibers, the GOF, that handle all the high-speed video data. But you also have 6 regular copper wires in there for power and control signals.
So the optical part is for the heavy lifting.
Precisely. And the biggest advantage there is that the optical path gives you total immunity from environmental noise. You get this incredibly low RF framey profile.
Radio frequency and electromagnetic interference.
Yep, which is critical in, say, secure server rooms or medical applications where you just can't have any interference.
Okay, so that fiber core is key for noise immunity. But what about actually installing it? I mean, pulling 100 meters of optical cable sounds delicate. They're usually so fragile.
That's a great question, and they've clearly thought about that. So even with the glass fiber, the cable has a minimum bend radius of just 35 millimeters.
Wow, that's really tight.
It is, and it has a UL-CMPO-F plenum rating, so it's certified for use in airspaces, above ceilings or in raised floors.
And what about the ends? Getting a big connector through a conduit is always the worst part.
They thought of that too. The connectors are actually mini DisplayPort, or mDP, and they are tiny. Less than 8 by 11 millimeters across, so they're super easy to pull.
That adaptability is huge. I did notice they come with mDP plugs, but most professional gear I see uses the full-size DisplayPort connector.
Yeah.
So are you stuck using adapters?
No, and that's the clever part. They actually include these 2 detachable docking connectors.
Oh, okay.
They just snap right onto the mDP ends and give you a secure, full-size DisplayPort plug. It's even got a locking pin. It completely eliminates the need for a flimsy dongle, which is always the first thing to fail.
Right, always. So we're moving all this data, converting signals from electrical to optical and back. That sounds like it needs power, a lot of it. Is there an external power supply you have to plug in?
Nope. That's another key feature. It's an ultra-low power design. The cable draws everything it needs. Less than half a watt directly from the DisplayPort source.
No wall warts. I love
It's
that.
essential for those mission-critical jobs like airport signage or a broadcast control room. You need reliability. The source material even points to a mean time between failures of over 150,000 hours.
And they're TAA compliant, so they can be used in government projects.
Exactly.
So just to sum up the raw power for you listening, we're talking up to 8K and 30 hertz, or even 5K at a really smooth 60 hertz with deep color. And the audio, you get up to 32 channels of uncompressed PCM audio. It's just an insane amount of data going through one cable.
It really is. I think the aha moment here is that these AOCs are the technology that bridges that gap between needing massive bandwidth, like 32.4 GBPs, and needing to go a long distance, like 100 meters. They do it while keeping the installation simple and self-powered.
They solve the distance problem without creating a whole new power management problem.
You got it.
So here's a final thought to leave you with. We know the video, all that heavy data flies across the optical fiber. But the really critical control signals, things like ED for handshaking, link training, they still rely on the copper wires. So given that dual reliance on both light and copper, what does that tell us about the future? Will we ever have a purely optical connection, or will copper always be that necessary anchor for control, even as speeds climb past 32 gigabits? Something to think about.